students. So starting with the next topic of our unit 3, which is digital logic characteristics. इसके characteristics में we are now as a last lecture we have already talked about the TTL total pole arrangement for NAND gate circuitry. देखो हमने क्या करा था? We made a NAND gate using a total pole arrangement of TTL, that is transistor logic. Now this TTL arrangement, ये जो TTL arrangement है जिसमें NAND gate हम बना रहे हैं, इसके अंदर लास्ट लेक्चर में हमने एक ऐसा arrangement पढ़ा था जिसमें there were two resistors and they were made one above another and in between them there was a diode to form a special arrangement. और जिस arrangement के कारण we named it total pole arrangement. Now there are various other forms in which the NAND gate can be formed and those are एक और circuitry है TTL का, that is known as open collector TTL. Now what is this open collector TTL is like? Let me show you the circuit diagram. See here, basically this is how TTL are classified, and on the basis of output TTL can be classified as open collector output TTL circuit. Now what is this open collector output means is that if you can recollect, अगर याद होगा कि हमने पिछले डायग्राम में I mean total pole के arrangement में we can recall, तो याद होगा we had Q1, Q2, Q3 and इस Q3 के ऊपर we had a Q4 और इनके बीच में एक डायोड था and this Q3 and Q4 was what forming a total pole arrangement. Now हमने यहाँ पे क्या करा है? We have removed the Q4 transistor and along with the transistor we have also removed the diode here, which was in between Q3 and Q4. So अब यहाँ पर हमारा जो output है, see this is the output here, okay? जो Y है, this Y is denoting the output. Now my output is only connecting to Q3. Now consider that if I'll provide any input and let any of them be zero, अगर ये कोई भी एक zero है, so what will happen is कि this will drive एक AND gate है, it will drive all of them. I mean this transistor Q2 as zero, and now this Q2 has the connection to Q3's base, and hence it will drive Q3 to be zero. That means ये दोनों open circuit हो जाएंगे. Now if they are open circuit, that means ये line open circuit यहाँ से over हो चुका है. That means my output is connected to Q3 and Q3 is open circuited. So I mean if this circuit is open, then at least this must be connected upwards or somewhere else, at least कहीं से तो connection होना था ना इसका. But इसका connection Q3 के अलावा we have no more connection to, अच्छा Q3 से मान लो connect करके it can have the value as ground. But what about अगर इसको higher value चाहिए, I mean plus VCC positive value चाहिए, तो वो value इसको कहाँ से मिलेगा? For that value it should be connected to this VCC, and now it is not. Hence this collector is known as open collector. It is connected with collector current है and ये collector open है. It is not connected to any of the inputs which will provide a higher value, higher logic value. इसलिए हम इसका नाम देते हैं open collector. But now for its performing operation we need this output to be connected to some logic higher value. इसको connect करने के लिए इस VCC से we use a resistor. इसको हम load resistor RL बोलते हैं और it is basically a pull-up resistor. Now, what is a pull-up resistor? Pull-up resistor क्या होता है ना? It is that resistor which will help your circuit to have a higher value. देखो, up pull up यानी it ups the value. तो ये क्या है? This circuit is now output is connected to VCC. So now अगर ये VCC connect होगा, तो फिर क्या होगा? It will have the value logic 1. So now that is the only difference. जब at least अगर मैं 1 दूँ, अगर इन तीनों पे A B C तीनों पे अगर 1 है तो it should provide you the value. यहाँ पे here it should be connected. अगर मैं 0 भी दे रही हूँ तो it should at least get connected to 1 value. ये तो open circuit हो गया, तो it should be connected with the input voltage level which had a logic 1. Logic 1 मतलब plus 5 volts 12. that is what is the open collector output TTL circuit that is all about. And the next type of circuit is in TTL we have two arrangement. One of this is the open collector output, and the next is Tristate output. Now what is Tristate output is, let me show you. See here, as I told you earlier कि हम TTL को किसमें classify, on the basis of output we classify it in open collector output हमने पढ़ लिया. Total pole output is the basic diagram. उसके बाद we have three state output logic. Now what is this three state output logic? It means that हमारे पास in all the circuit we have always input and output, है ना. Now three state, this is the total pole arrangement. ये देखो यहाँ पे Q3 and Q4, and here you have this diode which I have removed in the open collector form. Open collector में क्या करते हैं, इन सबको remove कर देते हैं, but this pipe is directly connected to a resistor which is pulled up to have a value logic 1. Okay, so now in three state output logic what we have is, this is the circuit which is providing us with three output. Now what are those output is, one is logic, one you can say as off means 0, on that means 1, and the third state is, it is actually a high impedance state. Okay, and it allows a direct wire connection of many outputs. Now what do you mean by high impedance state is, as you can see in diagram, देखो इसमें nothing extra is happening. It is similar to the total pole arrangement, but इसमें एक चीज क्या, output is also drawn from here in between Q3 and Q4. But the only difference is that we are having a special, you can say, connection in between. This Q3 के base से we are taking a diode, and I am taking जो next input है. देखो we have यहाँ पे Q1 पे हमारे पास n number of emitters होते थे, but यहाँ पे we have two input. नहीं देखो, मतलब यहाँ पे भी n input हो सकते हैं, but for currently नाम लेके होंगे two inputs, तो two input पे काम करके बताया जा रहा है कि A is the given input, data input, and the next input जो होगा ना, it is actually connected to the base के diode से connected है, and this connection is a third connection. Rather than showing this connection giving through the control input, rather than showing, you can directly say that ये एक enable input है. And what happens is that अगर if we are providing this data input as, ये चाहे 0 data input is A, whether be it 0 or 1, अगर मैंने इस जो enable bit है ना, मतलब ये जो Q1 पर वैल्यू है जो डायोड से कनेक्टेड है, if I had made this 0, तो यहाँ पे जो मुझे आउटपुट मिलेगा, फाइनल आउटपुट, it will be a high impedance state. That means it will be a new state which is between Q3 and Q4 is a high impedance state. And if we provide enable to be 1, तो क्या होगा, आउटपुट पे मुझे, अगर मैंने इनपुट 0 दिया है तो I'll have, it will act as simply, it will act as inverter circuit. तो अगर मैंने यहाँ 0 दिया तो it will act as 1, and यहाँ पे 1 दिया तो it will act as 0. So that is what is you meant to study about the three state output logic, that we have three states. One is 0, one is 1, and one is high impedance state. And that high impedance state is achieved only when you make this point as, in this enable point as 0. So then you will have here high impedance. Okay, so that is about all these TTL arrangement in a three-state output logic, and another is the open collector output logic.